Okay, just in case you still don't believe me, I'd like to engage you in a quick exercise which really illustrates the extent to which the kinds of biases and decision traps into which we can fall can negatively affect our decision making. And I'd like to engage you in an exercise called Let's Make a Deal. This is actually the name given to a game show in the United States. Is it a game show that anybody's heard of? Daniel? Yeah, Leanne? Yeah, people who've spent time in the States might be familiar with it. It's essentially the equivalent of Deal or No Deal. You know, the sort of game show in Australia where people sort of, which appears to be a guessing game. Is that fair to say, Daniel and Leanne? Yeah. And for the purposes of this exercise, what I'd like you to imagine is that we're on a game show. I'm the host, and collectively I'd like you to act as a contestant. The goal of the exercise is to win a prize of significant value. And what I want you to imagine is that there are 3 curtains behind me as they are on the screen. Behind one of the curtains is $100,000 in cash. I would suggest significant to most people. Yeah? Behind the other 2 curtains are goats, as in animals. All right? The goal, again, other things being equal, some people say, I want the goat, and I've heard all, like, let's say you're going for the money, right? The goal is to win the prize of significant value, okay? So what I'd like you to do is pick a curtain. Can we pick a curtain collectively, make a decision? 1 in 3 probability, no tricks here. 1 in 3 probability, can we pick a curtain, A, B, or C?
And we all collectively have to agree.
Well, let's aim for consensus, shall we say, Leanne?
I'll say B.
Fiona's taking the lead. B, are we happy with B? Again, 1 in 3 probability, completely arbitrary.
I was thinking C.
Thinking C. There's always one, always one who picks C. Well, it's more than one now.
Not the middle.
Not the middle?
The middle. I'm with you. Not the middle. Wow. Yep.
I'm going to go with B. Why not? Simply because it was the first. Let's go anchoring bias. It was the first piece of information put forward. So can we agree on B for the purpose of the exercise? Collective? Okay. We've chosen B as a means of trying to win the $100,000. Okay, I want to be clear on this. What I'm going to do now is reveal a goat behind curtain C. So the curtain comes up, okay? I'm not going to do the goat impression because all credibility is lost at that point. I've done it once or twice in the past. Curtain comes up, I reveal a goat behind curtain C, okay? Now, before I go to the next question, we understand, of course, that because there's a prize of significant value behind one of the curtains and goats behind the other 2 curtains, that no matter what you choose, I can reveal a goat. Does that make sense? And there's no chicanery. I'm not switching goats around and so forth, all right? Nothing's moving, okay? So I'm going to reveal a goat behind curtain C. Now what I'm going to do is provide you collectively with the option to switch to curtain A. Would you like to switch? Daphne?
No, I'm more inclined to stay with curtain B.
More inclined to stay? Sam?
Stay.
Stay? Paula?
Stay.
What about you, Ben?
I'm happy to stay.
Happy to stay? Would anyone like to switch?
Yeah.
You would? Okay, so we've got a significant number in the room here who would like to stay, and Leanne's out there saying she'll switch? Yeah? Okay. Matt?
Well, I was originally with A and I would have stayed with A, so I won't switch my choice, but I would
Okay. Imagine the equivalent if you'd chosen A. Okay.
stick
Yeah.
to my first decision.
Georgia?
Switch.
Switch? Fiona?
I'm going to stay with B.
Okay. So we've got 2 people who would switch, Leanne and Georgia, is that right? Yeah. The rest of you would like to stay. Okay. My next question is, should you switch? In other words, is there any advantage in a probabilistic sense, in terms of probability or likelihood of winning the prize, to switching? Is there any advantage to switching? Should you switch?
Well, given that C is out of the equation now, it's a 50-50 chance. So it doesn't matter which curtain you choose.
Are you sure?
Yeah.
Not now. Not since I've asked that question.
No, it's not 50-50.
It's not 50-50.
I've seen the maths behind this. That's why.
Oh.
You've seen the maths behind it, yeah.
That's why I'm being quiet on something. I've
Yeah.
seen the maths behind it.
No, I appreciate that for the purposes of the exercise. In fact, and this is absolutely true, one of the sessions I ran of this course a number of years ago, there was a guy sitting in the back corner of the room with his arms folded, just looking incredibly relaxed. And at the end I said, what were you thinking? He said, I was on Deal or No Deal a couple of years beforehand, and I lost a whole lot of money because I didn't understand this. Yeah, he'd actually been on the game show. Quite extraordinary stuff. You know, what are the chances? So Fiona doesn't think there's any advantage to switching. What about the rest of you? Do we think that there's an increase in likelihood in terms of winning the prize if we switch to curtain A? What if I was to suggest to you that if you do switch, the likelihood of winning the prize goes from 1/3 to 2/3? So what, 33% to 66%, roughly? Does that make any sense? Daniel? Makes sense to you? Please.
As I've seen, and I'm trying to remember the equation in my head. I know the mathematics behind it. It's not 50-50, although it seems that way. It's not. Once you eliminate the first one, it actually changes it from a 1/3 option to actually a 2/3 option if you do change. Yeah.
That's right, yeah. And what we're not going to do today, because this was something that when I studied this with Stanford, we spent half a day on this, all right? This was debated in journals for 20 years. The reality of probability is that as counterintuitive as it seems to us that switching from curtain C to curtain A will actually be helpful. Sorry, curtain B to curtain A, once we've revealed a goat behind curtain C. As counterintuitive as any kind of advantage is from switching, that's precisely what happens. And yet, I would suggest that there's nothing intuitive about that. The idea of switching curtains when given the opportunity, that will increase the probability of winning the prize. The question then becomes why? Okay, the short answer is that if your original probability when choosing a curtain is 1/3, what do the remaining two have to be? Did that just click for you?
Yep.
Yeah, that's right. Now, what will probably happen is that if you're interested in understanding the mechanics behind this, you might go and investigate it online. And what I'd recommend is what's called the Monty Hall exercise. It'll illustrate the mathematics behind it, okay? And what will probably happen is that it'll be on the edge of your comprehension for a little while, and then it will go, and I get that, makes sense now, yeah? But it's not intuitive, and this is the point. I've said here, common sense is exquisitely adapted to handling the kind of complexity that arises in everyday situations. And for those situations, it's every bit as good as advertised. But situations involving corporations, cultures, markets, nation states, and global institutions exhibit a very different kind of complexity from everyday situations. And under these circumstances, common sense turns out to suffer from a number of errors that systematically mislead us. And this is the point. What seems intuitive to us, what seems rational, sensible, and reasonable, isn't necessarily always so. Reality doesn't really care whether or not something is intuitive to us. And I think that exercise illustrates the degree to which the correct answer can be so counterintuitive, that there's such an advantage to switching rather than sort of staying with the curtain you've originally chosen and just thinking that it's 50-50 probability from that point on. Does that sort of make sense to people? It can be a little bit confusing, but well worth trying to get a handle on.